Hello students, welcome to Modern Group of Education, Kolkata. So today we are going to start electric field portion of class 12 chapter, class 12 electricity 1 chapter, electricity 1. Okay. So if you do not watch the previous videos, then please go and watch the old videos, previous videos of these chapters and then come here. Okay. So what is electric field? Electric field, that means a field or a region. Okay. That means a region where a charge is placed. Okay, the near to a charge there is a region that where a third charge is present, then it will experience a force. It will experience a it will experience an attractive force or repulsive force, depends on the nature of the charge. Okay, what is electric field? Electric field is a region around a charge, around a test charge. Okay, so I already told you about the properties of test charge. So electric field is the region around a test charge in which if another charge is present, then it will experience attractive or repulsive force, depends on the nature of the charge. Okay, depends on the nature of the charge means if the charge is positive and this test charge is always positive, then it will repel each other, and if the another charge is negative, then it will attract each other. Okay, so this is the electric field. It is a region. Okay, say there is a plus charge, test charge is always positive in nature. So in this region there is a, this is the electric field region. If a third charge is present in here, which is a negative, then it will get attractive force to the positive charge. Okay, so this is the electric field. But what is the electric field intensity? The measurement of electric field, whether it is intense or how much intensity is there for the electric field, it is higher or lower. So this is the electric field intensity, just like the gravitational field intensity. Field intensity is measured by the value of small g. Okay, but here electric field intensity is measured by E vector. Okay, so this is the electric field. The total chapter of class 12, this chapter electricity 1, it is purely based on the electric field. We are finding the electric field of different in the next lectures. We will find the different electricity of charge, different charges like infinite charge, linear charge, etc., dipole, etc. Okay, so electric field is the most important part of this chapter. So electric field E has different values of all the charges, but for a point charge, for a point charge for a point charge, the value of electric field intensity E is equal to kq by r square, where q is the charge, and r is the radius of the charge. Okay, kq by r square, electric field intensity for a point charge. Now here a question comes that what is a point charge? Point charge means just like a point. Point charge is just like means a point. Yes or no? No. A point charge can be of any type of charge which is spherical in nature, because a spherical charge can be of point charge, but a point charge has no limit of its radius. Okay, a bigger charge, say a charge in our room, total room there is a spherical charge, it can behave as a point charge. How? The point charge, this term is a we can say that this is a relative term. That means it depends on human to human, person to person. Okay, so point means, we know that point means that has no length, no width, no length, no width, and low height, etc. But for a point charge can be of any type of charge which is spherical in nature. Say this is a room, and there is a bigger charge. total the radius of the room, the size, the radius of the charge is the radius of the room. Okay, this can also behave as a point charge, because if we see a point charge, if we see this charge from 5 kilometers, 6 kilometer distance, then it will act like a point charge. So a bigger charge can behave as a point charge. Okay, point means, point is a relative term. Okay, so for a point charge equal to k cube by r square, but for different charges has their different electric field intensity values. Okay, for point charge it is k cube by r square, where k is known as Coulomb constant. We already know. Q is the value of charge and r is the radius of the charge. Okay, actually it is not the radius, it is the distance where electric field intensity will be measured. It is the distance from the charge where electric field intensity will be measured. Actually this is the r. This the radius of the charge, the r is not actually the radius of the charge. It's a distance from where a third charge, the electric field intensity will be measured from this charge. Okay, clear? Now we will do a numerical after this, and do the next questions, next topics. This is the properties of electric field intensity. Okay, properties of electric field intensity. Electric field intensity, what is a property? Properties are like electric field intensity for a point charge is k2 by r square. I already told you about that. For a point charge it is k cube by r square. Okay, and another thing is that the electric field intensity is a vector quantity, so we have to separately calculate the value, and we have to calculate separately the direction of electric field. The direction of electric field is just like the force acting on the charged particle. The force, the value of formula of force acting on a charged particle is F is equal to QE. F is equal to QE. How this comes? We already know that F is equal to KQ1 Q2 by R square. That means KQ square by R square. If Q1 is equal to Q2, this is KQ square by R square. And I already told you that the electric field intensity is KQ by R square. So there is a multiplication of Q here. If we multiply Q with this, then it will be the force value KQ square by R square. So F is equal to Q. This formula is very much important. This is a very important formula. You have to know. You have to remember this every time. So this is the properties of electric field intensity. That means electric field is a vector quantity, and you have to find the value of the electric field separately and the direction separately. Okay, the direction of electric field is the direction of force acting on the charged particle. Clear? Now there is a question, we have to solve it. This is example. This is an example based on electric field, where four charges Q1, Q2, Q1 minus Q1 to Q1 and Q are placed at the corners of a square in order. One side of the square is A, and the electric field intensity at the center of the square. Here, this type of question is very important. This type of question comes in board exams. This type of question does not come in the NEET, JEE Main, etc. But you have to know the basic things. Okay, so at the center we are assuming that there is a test charge. Test charge means a positive charge. We are assuming that there is a test charge. So minus 2q charge will attract this charge, because it is a positive and it is a negative. Plus q will repel this like this. This plus q will repel the charge like this. This minus q will attract this like this, and plus 2q will again repel like this. But these forces are not same. These electric fields are not same, because there are some changes in values of q's. Okay, so you have to find all the forces. Let's say this is F due to 2q. This is F due to this force is F due to Q, this force is F due to Q minus Q. Okay, this force is F due to plus Q, and this force is F due to plus 2Q. Say, so you have to find all the forces separately. F due to plus 2Q, F due to minus 2Q, F due to plus Q, and F due to minus Q separately. F due to 2Q, in the electric field formula there is also, we have to find the electric field, no forces, electric field. E due to plus 2Q, E due to minus 2Q, E due to plus Q, and E due to minus Q. In the electrostatic, in the electric field intensity formula, we have to put the value of charge only, not the sign, because we are assuming that the charge is positive in nature, and we are separately find out the electric field values, and we are separately find out the direction of the electric field. So K Q, that means 2Q by R square. R means here, this is A, this is A. It is already told in the question. So this thing, this the diagonal will be root 2a, root over a square plus a square root 2a. So this is a by root 2, root 2a by 2, root 2a by 2, that means a by root 2. This thing, this line is from the center of this charge is a by root 2. So all the distances are same. So this is a by root 2 whole square, that means a square into 2. Okay. Okay. So next thing, K into 2Q into, say here same thing will happen, a square, K into Q by a root 2 into 2 a square, here 2Q by a square. So if we see this, the diagram, that here 4KQ by a square, here also 4KQ by a square, this is 2KQ by a square, this is 2KQ by a square. So this is 4KQ by a square, this is 4KQ by a square, here is 2KQ by a square, here is 2KQ by a square. That means here is 3KQ by a square. A force is acting is in there in this direction, that 4KQ by a square, and in opposite direction KQ by a square. That means electric field as a vector quantity, hence we can write that a force is acting with the value of 2KQ by a square in this direction. So this is 2KQ by a square in this direction, here is also 2KQ by a square. So the net force, will be in this direction, here and here. The forces are the electric fields are, sorry about the forces, every time I'm repeating that forces is the electric field, 2KQ by a square, here also 2KQ by a square. Okay. So what is the net resultant force? Net resultant force will be acting like this direction. This is root over of 2KQ by a square plus root over of 2KQ by a square. Okay. That means 2 times of 2KQ by a square. That means root 2 times of, here this is 4KQ by a square, 4KQ by a to the power 4, 4K square, K square a to the power 4, 4K square, K square a to the power 4. Okay. So this is 8K square is Q square to the power 4. 8 means 2 root 2. So this will be 2 root 2 KQ by a square. Okay. So the net electric force will be 2 root 2 KQ by a square. This is the ultimate result. 2 root 2 KQ by a square. 8 means root 8 means 2 root 2. Okay. Understood? Erasing all the lines, and I am repeating this one again so that you can easily remember the things and just feel the concepts. Okay. So erasing all the thing. Now I am doing the question with short method. There is no short method, actually. This is the first technique. That is, it will there is the electric force will act like this, and the force will act like this. So the plus q charge will repel this charge here, the plus 2q charge will repel this here. Okay. The plus q minus 2q charge will attract this light, and minus 2q will attract this light in this direction. So there will be the direction of, here two direction will be there. One is in this direction, here 2kq by a square, here 4kq square, 4kq by a square, here 4kq by a square, and here 2kq by a square. So okay, in this side actually 2q and plus 2q, here 4kq by a square. That is the wrong concept. This 2q will repel this charge in this direction, so 4kq by a square, and this plus q will repel this side. This is 2kq by a square. So the force will be in this direction. Electric fields are in this direction, 4kq 2kq by a square and 2kq by a square. So resultant will be in this direction, root 2k to root 2 kq by a square. Okay, and you have to find the angle separately, that this is 2kq by a square, this is 2kq by a square. So the angle with the horizontal you have to find tan theta or else something. Okay, so tan theta will be, if this is theta, if this is theta, sorry, if this is theta, then tan theta will be, if we draw this line, this is theta, so this is the perpendicular 90 degree. Okay, so this theta will be, tan theta will be difficult to find, but if we find the sine theta, then it will be very helpful for you. If we find cos theta, then it will be very helpful for you. Cos theta will be base by hypotenuse, 2kq by a square, base by the hypotenuse. Okay, 2kq by a square. So kq by a square, kq by a square got cancelled out to root 2 by 2, that means root 2. Cos theta will be root 2. Okay, so this is the angle. It will be cos inverse root 2. Clear? So this is the concept of this question. I think you have understood the topic. Now next to the going to the next page, the electric lines of force, properties of electric lines of forces. This is important. This is very much important, because many times in IITs also there are some questions from this topic. We will discuss this in later, but electric lines of forces are very important. Electric lines of forces, here you can see that the positive from electric lines are always emerging from positive charges, and it gets into negative charges. Electric lines are always emerging out from the positive charges and gets into negative charges. They do not form closed loop. Okay, they do not form closed loop. They do not form closed loop. That means it gets out, emerges out from positive charge and gets in negative charge, but does not emerges out from positive charge and gets in negative charge. Okay, so they are from closed loops. They do not from closed loops, sorry, and they are also symmetrical in nature. They are symmetrical in nature. You can see that they are symmetrical about this axis, symmetrical in nature. Okay, if we draw tangent on the direction of electric field, then it will give the direction of electric field. This is very important topic. If we draw a tangent on the direction of electric field, sorry, if we draw tangent on the direction of electric field line, electric field line, then it will give the direction of electric field. Then it will give the direction of electric field. That means electric fields are always tangential to the direction of electric field lines. Okay, and two electric field lines can never intersect each other. Two electric field lines can never intersect each other, because if they do so, at this intersecting point, there will be a two tangent which is in the which is in this direction and this direction. So in any point at any time, at the same time, there will be no two tangents. There will be no two direction of electric field. Okay, so this is impossible, etc. And there are more points, more topics for in the inside of us conductor. Inside of a conductor, there is no electric field lines. Inside of a conductor, there is no electric field lines. Okay, there is no electric field lines. Electric field lines always uh, gets into 90 degree to in the charge and emerges out also from the perpendicularly from the surface of the charge. That means if this is the surface of the charge, then electric field lines always emerges out just like this. This angle is 90 degree, just like this. Just like this angle is 90 degree. Okay, also gets into a negative charge with 90 degree angle. This angle is 90 degree. This angle is 90 degree. Okay, so these are the topic, these are the points you have to remember and do some questions now. Here some questions are there. Select the electric lines of forces drawn incorrectly, also given the reason for its not being correct. Select the electric lines of forces drawn incorrectly. Tell me which one is the incorrect line. So this is a plus charge and it is emerging out and gets into negative charge. This is the positive charge. So this is a wrong. Okay. This is also wrong because two field lines can never intersect each other. This is this positive charge. Here the electric field lines emerges out from the positive charge. Here also electric charge emerges out from the positive charge. But this is wrong because it is not perpendicular. Okay. Here positive to negative, but this from closed loop. This is wrong. Sorry. This is wrong. They do not form closed loop. Okay. So this is the question. Here the positive charge and positive charge, there is no field line in the two positive charges. This is wrong. Here this point is wrong because two field lines can never intersect each other. This point in this figure, this point is wrong because this is not 90 degree. This is also wrong and this is also wrong. Okay, the next page. A metallic sphere is placed inside an electric field. Out of 4 electric lines of forces, choose the correct one. This is the question of IIT. Okay, so in 1 2 3 4 you have to opt out the original question, the original figure. Which one is the correct answer? Say which one is the correct answer. In question in number 1, in number 1 line, the charge is passing to the conductor metal. Here a metal is written in that. That means it's a conductor. So 1 is wrong. 1 is wrong. In 2, there is no electric field inside of a conductor. Okay. In 3, this field line is also passing through the conductor. So 3 is wrong. 3 is wrong. In 4, there is no field line inside the conductor. But in between 2 and 4, if you watch that, if you watch this, that there is no 90 degree. but this is 90 degree. This is 90 degree. So 4 is the correct option. Okay. 4 is perpendicular to the charge, so 4 is the 4 is the correct answer. Now, equipotential surface, a surface where all the at all the points in a surface at all this is the equipotential surface is a surface where all the points have same potentials. Okay, this is called equipotential surface. That means this is a surface where number 1 point, number 2 point, number 3 point, all the points have equal potential. This is called equipotential surface. Equipotential surface are very important for your neat joint purpose, because most of the times question comes here. Question comes from here. Equipotential surface, if there are two important points from equipotential surface. Number 1, equal potential at all the points. Equal equal potential at all the points. And the second thing, most important thing, that no work is done in moving a charge from one point to another in an equipotential surface. Okay, because if there is no potential difference, then there is no work done. Okay, so no work is done in moving a charge from one point to another point in an equipotential surface. Now, there are some types of equipotential surfaces. Number 1, so please write down this. I am using this. There are some types of equipotential surfaces. Number 1, for a point charge. Say this is a point charge. So equipotential surface will be spherical in nature. Spherical equipotential surface, because all the distances are same from this charge. Okay, so equipotential surfaces for a point charge, this is the spherical equipotential surface. Second, for a linear charge or line charge, so this is a line charge. For this, the equipotential surface will be cylindrical. Okay, so this is a cylindrical. Okay, clear? Now, for a distant charge, that means a charge which is in very distance from us, distance charge. From distance charge, there is parallel electric field line coming. Always parallel electric field line comes. For this is the equipotential surface, and these surfaces are called planar wavefront. Planar equipotential surface. In class 12, in there is a chapter wave optics. There you will find wavefronts. Wavefronts are just like equipotential surfaces. Okay, so for a distance charge, this is a planar wavefront, planar equipotential surfaces. Okay, clear? Now next topic, types of electric field. Electric fields are two types. One is uniform electric field, another is non-uniform electric field. In most of the cases in class 12, you read about the uniform electric field, but there are some topics in which is related to non-uniform electric field. For a uniform electric field means parallel and equidistant field lines. Parallel and equidistant field lines are known as uniform electric field. Let's draw through the line option. So parallel and equidistant field lines are known as these are the uniform electric field. In uniform electric field, if I in next topics, all the formulas are valid for uniform electric field, but for non-uniform electric field, the direction of field lines are not equal. Okay, these are the non-uniform electric field lines. Okay, there is little some very little concepts about non-uniform electric field. We will learn about it later. Next, now comes the derivation. So I am completing this lecture in here because derivation part will cover new lecture, new videos. Okay, so please go and watch all the previous videos and come here, and please continue the lecture till the end. Please subscribe if you like the video, and share the video to your needed friends. Okay, tata.